Hello everyone, today we will be talking about this. This is it's a basic resistance tester which uses LEDs for indication, and it can be used to test resistors for open circuit, capacitors for leakage current, diodes and transistors for proper characteristics. And it can be used as a continuity tester too. This third green wire over here is only used for transistors, and the red and black wire used for everything else. If I short these, the LEDs turn on, as you can see. It's literally invisible on the camera under studio lights, but if I hold my hand over it, you can see them glow. I'm not really sure why there is a red and green light. I did not design this circuit, by the way. A very nice YouTuber by the name of DiodeGoneWild designed it and has posted it on his website, danyk.cz. And it is quite an interesting website full of plenty electronic schematics. And this is a continuity tester. You can also use it to test capacitors for leakage current. So here are, here are some capacitors, and let's just, for example, do a 400 volt 15 microfarad one. And let's go ahead and hook up one pin, and so that you can see the LEDs, let's tap the other pin to it. The LEDs blinked as the capacitor was charging up, and they have remained completely off, indicating that there is no leakage current in the capacitor. If there was leakage current, then the LEDs would ever so slightly glow. And of course, it can be used to test resistors, but it can only test resistors for open circuit. If the resistor is open circuit, then the LEDs will be off. And open circuit resistors only really happen when the resistor has experienced an overload. But it can also test diodes. So, for example, here is a LED. Let's hook up both of the pins and see what it does. It lights up. This is a pure green LED, so it lights up pretty bright, but and you might also notice that these LEDs down here also light up, indicating that it's a good diode. And of course, if it's an LED, the LED will light up too to indicate. And with a yellow-green LED, the more traditional kind, it just barely glows. And I think this is a very old one, so you can barely see it. And in fact, I might need to turn the lights off. Yeah, you can see it glow, but it's extremely dim, and you can only really see it from the angle where it emits most of its light. And it can also, it also works with much larger LEDs. Like, for example, this LED strip from a flashlight, it turns on, and if you reverse the polarity, it doesn't turn on, and the LEDs on the device don't turn on too. If the diode has failed, then then the lights would be on in both directions, because it wouldn't be acting as a diode and would be acting as a straight short circuit. Or if the LEDs don't light in any of the directions, then it would also be considered bad. Now let's move on to transistors. So here is a PNP transistor, a power PNP transistor, in a package. I don't know what the name of it is, but in this sort of package, this pin right here is the base. And it doesn't matter how you connect up these two pins to the collector and the emitter, but for transistors, you have to connect this pin right here to the base, the green wire to the base. And let's go ahead and connect the red wire to this pin, which is probably the collector or emitter, and of course connect the black wire to the other pin. And now you might notice that if I get a good connection over here and don't let the pins touch, the LEDs are off, but if I flip the switch, the LEDs turn on. And flip the switch, they turn off, flip the switch, they turn on. This is not a power switch, this just tests between different types of transistors. You set it to this position for PNP transistors or P-channel MOSFETs, and you set it to this position for NPN transistors or N-channel MOSFETs. And a good transistor will show both LEDs on in one position and no LEDs on in the other position. So let's go ahead and check a different transistor. Let's go ahead and grab this one right here. It is BC547, which is an NPN transistor, and in the TO92 package, the middle pin is typically the base. So let's go ahead and connect it up like this. Connect one pin there and the other pin there. And you might notice now that in the position where the other transistor's LEDs was off, this one is on, so that indicates that it is an NPN transistor. And yeah, there you go. So this is a pretty useful tester that can test components simply, but it is not nearly as fully featured as a proper transistor tester that you can get from the Chinese mafia for 7 or 8 buckaroos, I guess. Maybe not now with the tariffs, but that's how it used to be when I had mine. But unfortunately, mine has suffered a catastrophic failure when the microcontroller failed short circuits, so it is no longer with us. I made a video where I attempted to fix it, and yeah, just want to mention this again. This is not my idea. danyk from DiodeGoneWild has designed this circuit and also made the schematic, and it can be found on his website, danyk.cz. And let's take a look at the schematic. So it's just made up of a power supply, 9 to 12 volts. I'm just using a 9-volt battery, Rayovac, nice brand, especially since one of their AAA batteries has exploded in my bin. And it goes to this switch, which basically just tells the base pin, which directs connectly to the base, to connect to either the plus or minus, depending on whether or not it's a PNP or NPN transistor. For a NPN or N-channel MOSFET, it will be in this position to send a positive voltage to the base or gate, and for a PNP or N-channel, then the base will be pulled negative, because that's how those transistors work. And then this little circuit over here is what really makes the magic, because if this was just a simple LED and resistor in series with these two contacts, then it wouldn't be able to measure higher resistances. So this little circuit over here basically amplifies the voltage so that it can easier light up these two LEDs. And anyway, that's about it for this little tester that I did not design. In case you're wondering, it's okay to leave a 9-volt battery connected to this thing because the quiescent current is very low unless you accidentally short these two pins, in which case the LEDs do turn on, but I can't imagine that it draws very much current at this state.